Hi, students. In this lecture, I am going to discuss problems. Let us see first one. So, question number 20 and 21 discussed in the last lecture. Let us see now 22. A liquid is kept in a cylindrical vessel which is rotated along its natural axis, given vertical it is. The liquid rises at the sides. If the radius of the vessel is 5 centimeter and speed of rotation is 4 revolution per second, then the difference in the heights of the liquid between the center of the vessel and its sides in centimeters. Let us see how to start. Cylindrical vessel rotation about its natural axis, which is vertical. At first, make the diagram. So, first of all, it is a cylindrical vessel. It is now rotating about its own axis, or you can say natural axis, which is vertical, means along its axis. Axis of rotation is along its axis. Rotating now about this axis. Given omega, let us say initially level was like this. This was the level, right? When it starts rotating, shape of the free surface, it becomes now paraboloid. It will rise at the edges. It will be like this. So if you imagine a parabola, suppose like this is y-axis. If you rotate now this parabola, if you rotate this parabola, we get one shape. Means that a parabola traces one shape, and that is known as a paraboloid. I'm writing here. That shape is a paraboloid. So shape of the free surface, it will be paraboloid. Okay. Now in this, we have to calculate separation between this point and this corresponding point. Between these 2 points, what is now separation? Okay. Let us see how to start. Let us take initial height. Take it as y naught. It is y naught. And suppose this is now corresponding to y minimum. Okay. Let us take now this point as origin. So taking bottom of the vessel, that midpoint, that center point as origin. This is now x and this is y. This is now y minimum and this is y naught. And this is now y maximum. So we want to find now y maximum minus y minimum. Y maximum minus y minimum. That is a question given. Let us see. So first consider the free surface. It is now paraboloid. This is axis of rotation. Let us consider one small element on surface. I am taking somewhere here. Its distance from the axis, that is x. Take a mass dm. Now solve the question with respect to that rotating frame. Okay. Then you can see this point follows now circular path in ground frame. It follows now circular path in ground frame. When we are solving with respect to that, it is now a non-inertial frame. Then we have take pseudo force, that is dm into acceleration is a, which is equal to r omega square. Dm into r omega square. Its weight mg downwards. It is a dm into g. Now, resultant of these two must be normal to this element. That means if we consider, so take one tangent at that point. So take a tangent at that point. Suppose that tangent makes angle theta with horizontal. Okay. Now this force resultant of these two must be normal to that tangent. So why it is normal? Because with respect to that element, that means now liquid is stationary. So when it is in equilibrium, net force must be normal to the surface. Because if there is any force along the tangent, then liquid flows. Okay. So this is now resultant of these two, which must be normal to the tangent. So if this is a theta, this also theta. See carefully. This is vertical, means normal to horizontal. This is normal to tangent. So between these two angles theta, then these two are normals to those two lines. So between the normals also same angle, right? So now it is just like there are two vectors which are mutually perpendicular. And this is now resultant of those two. Then tan theta equal to opposite by opposite means it is now dm into x omega square by adjacent side dm into g. That is now x omega square upon g, because dm gets cancelled, and that is equal to dy by dx, because this is the angle made by tangent with horizontal. That's why it is equal to dy by dx. Now simplify this. Dy, that is equal to, and take omega square by g outside, integration of x dx, integration of dy. Now see limits. When x equal to 0, when x equal to 0, what is the y coordinate for this lowest point? It is y minimum. Okay. So it is y minimum. And when it is x, so take it as y. Now simplify this. Y minus y minimum is equal to omega square x square by 2g. Right? Right. Now focus carefully. When you are taking x equal to r, x equal to r means correspond to that y coordinate, x equal to r, y will be maximum, right? That means when I am taking x equal to r, y will be maximum. That means y maximum minus y minimum, that is equal to omega square r square by 2g. See carefully. I am taking When x equal to r, x equal to r, what is the y coordinate corresponding to liquid? X equal to r, it is maximum. That's why it is y maximum. Okay, minus minimum. Omega square r square by 2g. Let us now make calculation for this. Right now, see what is given here. Values, omega value coming to r given 5 centimeter. Omega is given 4 revolution per second. 1 revolution means 2 pi radian. So 4 into 2 pi radian per second. Okay. Remain just a calculation part. See once calculation part. See how much we get. That value equal to omega square 16 2 pi. That is 4 pi square. That is omega square. R square. R square is 25 10 power minus 4. Sorry, 25 centimeter, right? 10 power minus 2. So 10 power minus 4, right? Upon 2g. 2g value 9.8. It is given that take pi square equal to 9.8, right? So now calculation becomes easy. Pi square and 9.8 cancel. 2 in 16, 4 times 425 100. It is now 425, so 100 into 4. It is 400. Let me cross check once. Omega square, omega value 4. 4 into 2 pi, so 16. 2 square 4 pi square. R value given 5, so 25 10 power minus 4. Omega square r square by 2g. Pi square 9.8 cancel. Sorry, this is 8. This is 8. So 425 100, 800. So y maximum, let me take it as some value y. That is y dash. So this is y dash. Y dash equal to 800 into 10 power minus 4 meter. And if you want to convert into centimeter, then this becomes now into 10 power 2 centimeter. Then 2 and 2, 4 gets cancelled. It is now 8 centimeter. Okay, that is the answer. Now let us focus how to get this y minimum and y maximum in terms of y naught. Okay, so let us take now this as one equation, y dash, that is one equation. So here if you observe this paraboloid, its volume will be, if you imagine one cylinder between these two lines, one cylinder, volume of this paraboloid, that will be equal to half of that cylinder. Okay, it's a volume I am writing here. That volume is equal to volume of paraboloid is equal to volume of cylinder is now this height equal to y maximum minus y minimum. Y maximum minus y minimum into the cross section area. That is the volume of the cylinder. If you imagine now cylinder here between these two lines, one cylinder, its volume will be equal to this height is y maximum minus y minimum into A. Now what we are saying is volume of this paraboloid, volume of this paraboloid is equal to half of this volume, half of this volume. Okay, that means volume equal to, see how much this volume equal to this volume equal to, I am writing here, total volume equal to, see total volume how much, initially height was y naught. Okay, so total volume equal to this area into y naught. Okay, so let me write this part here. I am writing here conservation of volume. So equating volume. So I got here volume of parabola, that is, this is the volume. That volume is given by this value, this expression, plus this volume. This volume is equal to y minimum into a naught. Y minimum into a. This must be equal to, this must be equal to y naught into a. Cross check once carefully. This part of the volume, that is equal to y maximum minus y minimum into a by 2. Okay, this volume. This remaining volume is equal to y minimum, that is a height, into area. That is equal to initial volume. Initial volume how much? Y naught into a. Is y naught into a. Right? Now simplify this. From this, see what we get. So from this, we are going to get 2y naught is equal to, throughout a gets cancelled, a and a gets cancelled. 2y minimum is equal to 2y naught. So 2y naught equal to y maximum plus y minimum. Let me take this as equation 2. So equation 1, y maximum minus y minimum equal to, here y maximum plus y minimum, right? Now from this, see what we get. If you take 1 plus 2, equation 1 plus equation 2, then y minimum gets cancelled. Then we are going to get y maximum. Y maximum is equal to y naught plus r square omega square by 4g. Next, y minimum, that is equal to y naught minus r square omega square by 4g. So these values you can keep in mind, y maximum and y minimum. Okay. Difference of these two is equal to omega square r square by 2g. Okay. Now you can focus how questions can be asked basing on these two. Okay. So now in this question is like, for what value of omega, for what value of omega, the central point of the base is visible. Question is like, for what value of omega, the midpoint of base of the cylinder is visible. That means what is y minimum? It becomes 0, right? Shape becomes like this. Okay. That means if center of the base is visible, then y minimum equal to 0. I will take here 0. Then we get the corresponding value of omega. Okay. For example, for what values or for what value of omega, liquid is now about to spill outside. About to spill outside means, see what will be y maximum? Y maximum will be equal to height of the cylinder, right? About to spill means this will touch now the edge of the cylinder. Touching means y maximum equal to h, right? It is total value is h. Then take now in this place length or you can say height of cylinder. Okay. Then we get corresponding value of omega. Suppose question is like y naught is h by 2. Okay. Let me draw here. Suppose initially filled up to h by 2. That means y naught value h by 2. Now for which value of omega liquid spills outside, then what happens is once about to spill, touching this h, touching means y maximum becomes h. Then h minus h by 2, it is h by 2. Then we get the value of omega. So like this, we can expect questions basing on these two. Okay. So I hope you got the clarity.